Alright, this is the last project I'll be filming today. Built this a few years back. It is a 575 watt HMI, which is, I think, just a normal metal halide lamp, just branded by Osram. It's medium arc, or hydrocarbon medium arc iodide lamp. And yeah, so I'm just gonna go over how I built it. It is battery powered. And then kind of just like how I use it. Yeah, so starting off with the ballast. The ballast itself is I believe the brand is Schneiderwork. They build these ballasts mainly for moving head applications and production applications. So it is a very well built, and I've had a lot of success with it. It's a very compact. The ballast itself is this lower portion. This is all cooling and fan control, but this lower portion is the ballast itself. Very compact, quite happy with it. Yeah, so then moving up, place it inside. Moving up, we have, this is the cooler for it. So the ballast itself, all the power control MOSFETs are mounted to this very thick copper block on the top here. So to dissipate the heat from that, you might recognize this heatsink from my 400 watt LED, where I had two of these. But basically I just mounted that to the top of this ballast, and yeah, so I also have two extremely powerful Delta fans. I believe that each of these is around 60 watts. So it pushes a lot of air. And obviously I don't need it running at full speed all the time. So I have a PWM fan speed controller running off this potentiometer here on the top that just controls the speed. So normally I'd be holding it like this, and I can just control the fan speed. If I feel that the ballast is overheating a bit, I could turn the fans up a bit, and then yeah, so I don't have to constantly run them at full speed, just to help conserve some more battery power. Yeah, so we have power input for ballast fans, which is also then relayed through this connector to the lamp head fans. And then we have the power input for the ballast itself. And yeah, so the actual handle for the ballast, it's just some bent aluminum rod that kind of hugs the center aluminum heatsink, and then there's this main U handle, U shape, that bolts onto either end, and that's what I hold. And yeah, and then you can see the connector that goes to the lamp head is just, I think, like a 30 pin printer cable, and then this is the main output of the ballast that goes to the lamp head. A little confusing that I use the same connector for the fan head and the actual power to the lamp head, but usually the cabling doesn't get mixed up between those two nodes, so I don't ever have to worry about plugging the batteries into the lamp head, and nothing would happen because it is an arc light, so you need a high voltage to start it. So yeah, I'm not too worried. But yeah, all right, so moving on to the lamp head itself, we can see the same cabling that plugs into here on the output end of the ballast is on the input side of the lamp head. Yeah, so I have some very thick 8 gauge silicone cabling, kind of just helps with the high voltage pulse that the igniter starts, or that the igniter initiates when the ballast starts. Kind of don't want to control it a little bit better, so I use some very thick insulation cabling. And then yeah, so power comes, yeah, let me just flip it on its back. So first thing, stress relief, just so that nothing ever disconnects accidentally. So from that stress relief, we can see that the main positive and negative go to the input side of the igniter over here. This is the igniter. It's just a standard metal halide igniter. I think it's specifically built for HMI lights, but yeah, it works very well. Ignites on the first strike every time. And yeah, so that's the igniter. And then from the output of the igniter, we can see some more stress relief. But these two cables go into the lamp base, and this is a ceramic lamp base holding the 575 watt HMI light in place. And then from there you can see these two L brackets on either side that I fabricated, one on either side. And that is what holds the bottom of the reflector casing. So you can see L bracket on either side extends up, and this is the I don't really know how to call it, the extension of the reflector that encases the bottom half of the lamp. And then you can see it is adjustable, so I just loosen these and I can adjust the reflector up and down in case it gets out of focus, because you do want that 575 watt light right in the focal point of that parabolic reflector to get maximum range. And yeah, you can see there's the light itself in the parabolic reflector. Yeah, so with that, I think it goes around a few miles. It is a fairly large emission tube. Sorry, just gotta focus it. It is a fairly large emission tube. So getting it directly in the focal point of the parabolic reflector is quite difficult. And you never really get a perfect focus. So did the best I could, and it goes quite far still. And then on the other hand, we have the other cabling coming in from this 30-pin connector. We can see the first set of colored cables breaks off, and that plugs into this display here, which tells me how much battery I have left on my fan power battery. And then I have two switches here. I have the first one, which is main power on, and then this one switches between high power and low power mode. So yeah, the Ballast itself does have two power settings. You can't dim these arc lights too far, otherwise they start flickering. But you can dim them to around 80%, 75%. And you do conserve a lot more power without the flickering drawback. Because if it does start flickering, you do shorten the life of the arc tube itself. But it does work well. In times where I don't need as much light, you can just flip it down and it draws around 450 watts instead of 750 watts, taking into account the losses in the ballast. So yeah, that's how you hold it. You can see you have very ready access to both of the switches. You don't really use them that often, but yeah. So then last part is extension off the handle is this very well mounted blower fan, and that just kind of circulates air into and around this cone. And the issue I was having was, before this fan was installed, was the silicone material holding this part of the reflector to the actual bowl of the reflector started burning a bit. So I keep it cool a little bit. It's not ideal that you're only cooling one side, because that could cause thermal strain, but it does work, and I haven't had issues with that silicone down there burning off since I've installed that fan. And I ran it for 45 minutes straight. So yeah, I think overall it's very stable. Once again, very well built. And you can see also this ceramic lamp base at the bottom connects through contact to this back large heatsink that helps suck some of that heat from entering where I don't want it, which is in this very sensitive, I believe it is rhodium, electroformed parabolic reflector, and it helps prevent any burn spots in that reflector by removing heat from this lamp base and convecting it out the back here. So yeah, let me move over and I can show you how I actually power this thing. All right, so now I do have everything connected up. Normally this half would be mounted in a backpack with the battery closest to my back, and then the inverter directly behind it facing upwards, and then these are just in a side pocket. So you can see these provide power for the fan. This battery, this cabling goes in. You can see ballast fans controlled by that knob. Takes a while to spit out, but yeah, plenty of cooling power. And then you can see ballast fan, sorry, not ballast fan, lampet fan is blowing air into that cone, and we have a display of our voltage left in the system. So we go over here, we see now this this LiPo battery is connected to a inverter. This inverter is capable of doing 100 or 1500 watts continuous, and you can see the output just goes straight to the input of the inverter. We have the lamp head connected to the ballast, and yeah, let's do a test. So flipping this first switch up here, switches on the light, and yeah, we turn off the lights. So you can see initially not terribly bright. You can see the deposits on the side as the mercury begins to vaporize. That very characteristic blue glow. Yeah, we can see the draw on the inverter, 130 watts. Battery voltage just dropping down a bit, 140. As that light continues to warm up, the Shinerwork ballast will increase power incrementally, going tube by tube. Say now we're drawing 230 watts, 310. You can see that it's getting significantly brighter. 460 watts. It warms up quite quickly as well. For a lamp, for a discharge lamp, it warms up quite quickly. So now we're up to 630 watts at 14.8 volts. So this battery voltage is dropping down a bit. Not that much though, it has plenty of capacity. So 660, let's get it up to that full 750, and you can see that it's quite bright. I don't really know, the lighting in my basement doesn't really do it justice, but yeah, it is extremely bright. Alright, so now I believe it is at full brightness, and you can just take a look. It is extremely hot. Yeah, it's very hot. Yeah, beam is quite compact as well. It stays relatively tight for a very long time, and yeah, goes a long way. You can see now we're drawing 670 watts, so not quite the full 750 I was seeing before, but still quite a bit. And yeah, you can see, just pointing at the ground, it is overwhelming the camera sensor. And yeah, that's pretty much it. I guess, yeah, so that's the full setup. We have the inverter, still quite cold, inverter sitting up a bit, and yeah, a lot of light output.